sales. So sales is a fact. When you apply aggregation, it brings certain business meaning. Let's take another example. So sales test, sales fact test. This is pass. Second example, assume social security number is numeric, right? The social security number is numeric, which is 6-digit numeric value. So when you apply person 1 social security number plus person 2 social security number, when you sum them, it has no business meaning. Numeric, you might find the sum of it, but no, it has no business meaning. So the given number can be fact, may be fact, may not be fact, depends upon you apply this aggregation. This is very high level test whether the member is a fact or not. There can be some very peculiar example where the member can be fact and can be dimension. I tell you one example like product price. Product price could be fact and could be dimension. Scenario 1, we want to compare, we need to find the product price growth chart. How the product price has been growing for last 6 months, we need to plot a chart on this. So every month we want to find what is the product price has been increasing. What was the price in January? What was the price in February? So this is one scenario. Scenario second, impact on sales. This is what we need to find out as a result of price. What is the impact of sales as a result of product price rise? In this example, we will get into detail. This product price is fact, whereas in this example, product price is dimension. So there are certain cases, you don't need to get into this in detail at this moment. There are certain cases where it is difficult to identify if a given member is fact or dimension. So best let your business decide it's a fact or dimension. Everything is a number for us. For a technical user, everything is a number. For a business user, every number has a business meaning. This is what the difference. So again, if you analyze requirement number second, we need to find out year-over-year sales growth. We apply our test and see what is the dimension. The dimension would be year and the fact would be every year. What is the sales? The fact would be sales growth percent. This could be my fact. Growth percent basically to be this member is calculated member. So you apply this test on each requirement and you get to know this information about what is fact and dimension. So the root of all requirement or analysis always moves around the facts and dimension. So the way we organize the dimension facts we call logical presentation of data. We also call modeling. So we are talking about the first model called star schema. Okay. In the star schema we have excuse me. The following are the items. We have fact tables, we have dimension, we also have some terms associated with granularities, drill down, drill up and slicing. These are basically two operations. The first thing is fact. What is facts? Facts are numeric measurements that present a specific business activity. Like business specific activity, like in this example, any requirement you take, we identify what is a fact. Average customer sales. So average customer sales is a fact. Customer name is a dimension. Channel sales versus promotion cost, right? We are doing promotion, we are using various activities to promote the sales. So what are the promotion mechanism or instruments are used? These are promotion instruments are used. As a result of this, the sales has been grown by this. So sales growth is a fact. Promotion techniques or instruments are my dimension. Any analysis consists of these two things. We need to figure it out. Okay, facts stored in fact table. There is a separate table which stores all these facts. Now if you remember, in a traditional relational database, we don't use a term called facts and dimension, we use a term called tables, and we never distinguish the information in terms of facts. The way we distinguish the information in terms of entities. So maybe I've got one entity for customer which talk about all customer information. Generally in transaction system, if you say the customer, customer information stored across many tables. Customer, correspondence, customer history, okay, customer personal info. So same information, the customer information is stored in multiple tables, right? Because a transactional model, whereas if I design dimension model, customer should be stored in a single table. So we have a customer dimension underscore customer. It's a OLAP model. In a simple word, we are denormalizing all this information into a single table. Why do we do normalization? In order to support insert and update operation, right? Whereas in a data warehousing, most of my queries are select queries, or it is used for data analysis. So if you look, all the requirements I analyzed all consist of data retrieval or reporting. So we don't need an insert and update operation. So the information we store in terms of facts and dimension. What fact consists of? All numerics. Let's see an example of fact. This is one of my model. I've got two fact tables. We'll take this model and go step by step way to analyze, correlate with the business requirement, finally build our solution. So in this example, you can see the tables are organized in terms of facts and dimension. What fact table consists of? My fact table consists of foreign keys. You can see product ID is a foreign key for product dimension table. Customer ID is a foreign key for customer table. Therefore, my fact table consists of foreign keys with respect to various dimensions and numeric facts, right? Advertisement cost, unit cost, sale tax, road tax, all these are. And all these numerics or facts, we eventually perform the calculation analysis. So if you go all requirement 1, what fact you need? Amount sold. Requirement 2, what fact you need? Sales and growth percent. Requirement 3, what fact you need? Average customer sales. Requirement 4, what fact you need? Promotion cost for each promotion channel and the sales cost, sales. Requirement 5th, what information you need? Projected versus actual sales. So forecast sales, the sales which company has forecasted, maybe 20